Hey, good evening, folks. Welcome to the Wolfenberg Time Bomb channel. It's quite a while since I posted anything on in English language. I posted a few videos in Germany, in German language, and now I think it's time to share some video with the latest results from Time Bomb 4. How is it progressing? Well, actually, what I did is I redesigned the power supply. Here is a new board inside, and I used this output transformer there, which had two secondary coils. Each was something like 320 volts. I used them in parallel, but since the output power results were not so striking, I decided to wire them now in series, which gives me something like 640 volts AC, and then rectify them with a bridge rectifier or selectable with a tube rectifier. And so under load with that one we are hitting now, well, 780 volts. There's a small idle current through the tubes right now, but that is really pretty small. I would say it's less than 10 milliamps per tube, because this is pure class B. We will be driving this amplifier. Nevertheless, the scope gives me pretty good indication. The signal is pretty clean. And I also redesigned now the power supply, because I use the, as I said, I put both secondary high tension windings in series, and I use the lower one of these to derive the screen grid voltages out of there. So there is some divider there. You see one white resistor, and there's another resistor, this green one. I won't get too close with the camera because we have really this whopping 780 volts. And there I'm deriving a screen grids right now of 327 volt, which is pretty reasonable. I posted a German video from my test circuit board where the screens were something like 400 volt, but that was far too much. And then I also have a small divider there which gives me something like 280 volts. And for the preamp circuit board, it's also better than the formerly the more than 350 I had there with the parallel windings. Yeah, the only problem with this design of the using it the secondary windings in series, I did have no possibility to tap it for the bias, so I had to find a different solution for the bias. I didn't want to use a second transformer there, just for cost reasons, and also, well, as an engineer sometimes you might think across some borders. So right now I'm using this makeshift thing over here. It's a cascade, it's a voltage multiplier, and this one is connected actually to one unused heater winding, 6.3 volts. So I'm feeding this with 6.3. The output of that one is then, with these 3 or 6 stages, is roughly minus 50 volt. That's fine. That's what I need for my purpose here, and it's working. I still have probably to think whether I can really use then these electrolytic capacitors here, or if I change it against real capacitors. That is not really obvious to me at the moment. I'm feeding it with AC, so I have the feeling maybe these bodies are not the right choice at the moment. But nevertheless, anyway, it's working right now. And yeah, probably we'll just have a look on the power, and I'm feeding my sine wave generator here. This Russian, it's a bit crappy. The signal is not absolutely clean. You see it on the bottom. There's a little notch there. One little spare part is missing in this signal generator, but it doesn't matter so much. So then the signal generator is now connected to Or is it? Wait, I use some stick. I don't want to grab into the circuit. It's connected here to the input of tube 4. I'm switched it to the clean channel. This has now this channel switch inside. You see here this big 6-volt toggle switch, which I connected in the meantime. And if you switch it on, this lamp comes up to indicate we're on the gain channel, but right now we just use the clean channel for this purpose. And okay, the wiring's still a bit spaghetti, and I will clean it up once everything is finished. Once again, yesterday I ripped out the old power circuit board, and I just put in this new one, so then I will use some of these cable binders and bind it properly once everything's done. Yeah, but now to the results, and that is something which I'm really happy about. So first of all, if we just increase the volume, we would see here on the oscilloscope then this second one is directly connected to the output jack. The output jack is connected here to my 400 watt load. The load is switched to something like 3.8 watts. Well, it's 15 ohms 4 times in parallel. I mean, we can be accurate, so just let's calculate how much that would be. 15 divided by 4 gives us what? Not 1 for sure, not. Once again, 15 divided by 4 gives us 3.75. Okay, 3.75, fine. Yeah. So everything is set already. I tried it out already, and we are running. Once again, the plate voltage is 780. This one is a true RMS meter also, so it's connected straight to the output, and it will give the output in RMS volt, which is then pretty easy to calculate the wattage, the output power out of it. So let's go and see the signals coming up very nicely. No crossover distortion. I'm really surprised. And we just go to the maximum. You see here on the bottom it starts clipping. I guess it's coming from the pentodune maybe, or it's just a limitation of the power supply. But nevertheless, it's still quite nice sine wave. Here I'm tapping the cathodes of 2 tubes of the push-pull pair. So we are here on a divider of 0.2, means we have 800 millivolts over 3.3 ohms resistance. So you have to divide 800 by 3, that is something like 240. So each tube is producing pretty well 240 milliamps, which is probably the design limit of that particular tubes. That's great. So I'm really squeezing out the maximum. And then here from the voltage, I mean, now let's have a look on the voltmeter, and woohoo, we see 20.92 volts AC, and actually this is quite easy to remember. This 3.75, that was our resistance. So we take this 20.95. Hallelujah, I'm too stupid to use this calculator. 20.92, or actually 95, the square, and then we divide it by 3.75, which is the load, and woohoo, we have 117 watts. This is quite whopping. The voltage has dropped down to 360 volts. The grids are here. It's now on 383 volts. Formerly they were on 330, because I think I have some lifting effects because I use the choke in the common minus line, and I think now with this power running through the choke I have some sort of ground lifting effect, which increases this voltage. So over the next days I'll probably experiment a bit with the position of the choke. I didn't want to put it in the high tension line because then I have 750 volts on this choke. The choke is over there against the chassis, which is quite whopping, and so if it's on the ground then it's just something like 30 volts above ground, which is more reasonable. Yeah, and the thing is now working. I mean, it's stable. And on the German video we saw some red plating which came from too high bias or unfavorable combination of bias and grid voltage. Now here we can check, but I didn't see any red plating now because the bias was rather low. So I'll just switch off the lamp here. We can carefully take a look at the tubes, but I'm just moving around here. But well, this is this is my voltage stabilizer. That doesn't count. Just careful because we have the anode caps are on 700 volt now. But see by yourself, there is absolutely no red plating at all. Means that this amp really delivers. And okay, let me switch on the light again. These tubes are specified for 20 watt maximum plate load for DC, but of course here we're running AC, we're running this signal through it. So, and I made a couple of calculations and Excel spreadsheets about AC plate load, so I have a good feeling about using this on 100 watt circuits, especially because there are also some designs for the EL34 where they use a pair of EL34 for up to 100 watts. And if you think that the EL34 is also specified for 25 watt DC plate consumption, then 100 watt is quite a much for a pair. But once again, with AC things are a bit different. The load curve follows even the square of a sine wave, so it's quite complex formula behind it. Doesn't matter right now, but all I'm saying is that don't be fooled by a 20 watt power for DC or for a pentode, for output pentode. On AC things are different. So anyway, but here we're running then on 25 watts probably per tube. With some reflection. No, this is fine. Yeah, let's check again. So we're down on 559 volts. We have still this 20.95, which is 117 watts now output power on this 3.5 ohms. The grids are on 380 volts. We are well below 400, which is good. And yeah, I would say this is probably in the range where I really wanted to have this amplifier. I mean, the first results with this parallel windings of the high tension was only, I mean, at best it gave me something like 66 watts or 66.6, but with quite a much distortion, and I wasn't too happy about it. So here we are now hitting 100, what was it? 117 watts, which is really whopping. So I would say I'm quite happy. For the next days, then I will still work a bit on this power supply. I think I should add some more filter caps, and I will also play a bit with the position of the choke, because the choke is currently, oh no, that's not the right diagram. I have updated one. Never mind, the choke is now in the, as I said, in the minus line, on the ground line, and I might try it out what happens if I put the choke again in the high tension part, if this voltage will still rise. But on the other hand, I mean, who cares? I mean, we have 117 watts. We could try one small thing if I find it. I have this temperature meter, so maybe we just give a shot on the tubes to see how hot they get. Oh, it's rather moderate, 111. Try this one. 118. 120. So I would say they're not even getting hot, and this nicely glowing thing, I think it's not getting hot too much. Let's see. 70. Okay, well, so obviously they're still quite far away from any overload condition. What about the output transform, the power transformer? Yeah, almost sleeping at 46 degrees. Yeah, so as I said, this body is rated for 250 watts, so obviously no overload there. When the design is finished, of course, I will give it something like burn in for 2 hours, and then we'll see. But now it's running already for 10 minutes, and nah, we're on 44. That's really moderate. The output transformer shouldn't get hot either. 32, no. What about the choke? The choke is 40. Okay. Still pretty relaxed. And just try my. What about? Yeah, this is my power load. This is my resistive load. 150 degrees. So that's the only thing which is getting hot here. That's cool. And I'm also a bit wet under my arms for excitement, since the amp really seems to start to deliver. So I think I've well deserved my German lovely Hofbräu Helles, and I will keep on drinking that. And that was all I wanted to share for you. I think what still needs to be done on this amp, I still have to play a little bit with the tone stack and with some coupling caps. I also have some HF, high frequency interference still slightly coming, so sometimes I hear something like a Russian radio, so I have to use some small picofarad capacitors shunting these signals to ground. But other than that, I think that was a major design step now, changing to this really high voltage, because remember, these tubes were originally meant to be in the horizontal output stage of TV, and you know that the horizontal output stage in TV really operates on pretty high peak voltages but rather low current, and I think that's exactly what we are doing here now. We have pretty high voltage and rather low current, so obviously the tubes like that much better than this low voltage and high current. Alright, I think that's all for the moment. Stand by for 1 or 2 more videos of Time Bomb 4, but I think soon the design will be finished and the amp is then ready for playing, and for sure that will be worth one extra video. Okay, cheers, thanks, and bye bye.